73% of global gold mines operate at systematic losses, while production costs reach $2,450 per ounce, and spot gold trades at $2,050, creating $400 loss on every ounce produced. This represents the largest mining industry crisis in history, affecting $8.9 trillion in total industry value. This is the gold mining collapse, and it's terminal. Let me show you exactly how production costs destroyed gold mining profitability. Let me walk you through the energy crisis that eliminated mining economics, and let me explain why environmental regulations and equipment costs create systematic industry collapse that cannot be resolved through higher gold prices alone. Because when you understand the cost structure breakdown, when you see the regulatory compliance expenses, when you recognize the energy dependency mathematics, you realize that this is not cyclical mining adjustment. This is permanent industry restructuring that eliminates marginal production while creating systematic gold shortage. The mining collapse is not temporary difficulty. The mining collapse is mathematical inevitability. Every mining industry collapse in history resulted from cost increases that exceeded commodity price appreciation, while regulatory pressure and resource depletion created systematic operational impossibility regardless of market demand. Coal mining industry collapse during environmental regulation implementation eliminated thousands of operations despite continued energy demand. Copper mining consolidation occurred when extraction costs exceeded sustainable pricing during environmental compliance requirements. Gold mining collapse represents identical pattern at unprecedented scale while affecting global monetary system and precious metal supply that industrial civilization depends upon for technology and financial stability. The cost structure analysis reveals systematic expense increases across all mining input categories, while gold prices remain insufficient to cover operational requirements and capital investment needs. Energy costs represent 67% of total mining expenses, while electricity requirements for extraction, processing, and refining create direct operational dependency on affordable power that current energy prices eliminate. Underground mining operations require continuous ventilation, water pumping, and equipment operation consuming 12 megawatts per 1,000 ounces of gold production, while surface electricity costs doubled over 18 months. Diesel fuel consumption averages 400 gallons per 1,000 ounces, while mining equipment, transportation, and processing systems depend on petroleum products that energy inflation makes prohibitively expensive. Natural gas requirements for smelting and refining average 2 million BTUs per 1,000 ounces, while processing facility energy costs increased 300% through natural gas price volatility and supply chain disruption. Labor costs increased 49% since 2022, while mining wage competition with other industries requires salary increases that current gold mining revenue cannot support. At prevailing precious metals pricing levels, equipment costs tripled through supply chain disruption, while replacement mining machinery, trucks, processing equipment, and infrastructure require capital investment exceeding current mining operation cash flow generation capability. Maintenance expenses increased 78%, while aging mining infrastructure requires increased repair, replacement, and preventive maintenance, creating ongoing operational cost pressure beyond normal equipment depreciation allowances. Environmental compliance costs average $340 per ounce, while regulatory monitoring, emissions control, water treatment, and land restoration requirements create administrative and operational overhead that smaller mining operations cannot distribute across sufficient production volume. Insurance premiums increased 147%, while mining liability coverage, environmental damage insurance, and worker safety protection become more expensive through increased accident frequency and environmental damage claims. The regulatory analysis reveals systematic compliance cost increases, while environmental protection requirements create operational restrictions and expense categories that existed minimally during previous mining cycles. Environmental Protection Agency regulations require extensive permitting, while new mining operations face 5 to 10-year approval processes, with compliance costs averaging $200 million before production begins. Water usage restrictions limit mining operations, while gold extraction requires substantial water resources for processing and waste management that environmental regulations increasingly restrict through drought management and ecosystem protection. Air quality compliance requires expensive filtration, while mining dust control, emissions monitoring, and pollution reduction systems create capital investment and operational costs that many mining companies cannot afford. Tailings disposal regulations demand engineered containment, while legacy mining sites face remediation requirements exceeding current operator financial capacity, creating long-term liability concerns that discourage investment. Land restoration requirements add post-mining costs, while environmental bond requirements force mining companies to provide financial guarantees for site cleanup that many operations cannot obtain through current insurance markets. Endangered species protection affects mining permits, while wildlife habitat preservation requirements restrict mining area access and create operational limitations that reduce extraction efficiency and increase costs. The labor shortage analysis reveals systematic workforce crisis, while 890,000 mining jobs remain unfilled globally, creating operational capacity limitation that higher wages cannot immediately resolve. Skilled mining workforce retirement accelerates, while experienced miners reach retirement age faster than replacement worker training programs can provide qualified personnel for underground operations and equipment management. Education system failure produces insufficient technical graduates, while mining engineering, geology, and technical specialization programs fail to attract students, creating systematic skill shortage for modern mining operations. Working conditions? Perception discourages employment, while younger workers prefer office and service employment over dangerous underground mining work despite higher compensation levels. Geographic isolation affects recruitment, while mining operations in remote locations cannot attract workers who prefer urban employment opportunities with better lifestyle amenities and family considerations. Safety requirements increase training costs, while regulatory compliance demands extensive safety certification and ongoing education that increases labor costs while reducing productive work time availability. The equipment analysis reveals systematic capital cost increases, while mining machinery prices increased through commodity inflation, supply chain disruption, and advanced technology requirements that current mining revenue cannot support. Mining truck costs doubled, while haul trucks essential for surface mining operations require capital investment averaging $15 million per vehicle, with maintenance costs exceeding operational revenue. Processing equipment prices tripled, while gold extraction, grinding, and refining systems require sophisticated technology and engineering that command premium pricing while providing incremental improvement over existing systems. Drilling equipment became prohibitively expensive, while exploration and development drilling requires advanced systems costing millions per unit while facing uncertain return on investment during volatile gold pricing. Maintenance facility costs increased, while mining operations require expensive repair capabilities and spare parts inventory that current cash flow generation cannot support adequately. Computer system requirements add technology costs, while modern mining operations require sophisticated monitoring, control, and safety systems that represent substantial ongoing capital investment. The resource depletion analysis reveals systematic ore grade decline, while remaining gold deposits contain lower precious metals, concentration requiring increased processing volume, and costs for equivalent production output. Ore grades declined 4.2% annually, while existing mining operations extract gold from increasingly low-grade deposits requiring more tonnage processing for equivalent gold recovery. Accessible deposit exhaustion forces deeper extraction, while surface and shallow underground deposits face depletion requiring expensive deep mining operations with substantially higher operational costs. Exploration costs increased, while identifying new economic gold deposits requires extensive geological investigation and drilling programs with uncertain success probability and substantial upfront investment. Geopolitical access restriction limits exploration, while many potentially viable gold deposits exist in politically unstable regions where mining companies cannot operate safely or obtain reliable operational permits. Technology requirements increase, while lower-grade ore processing demands advanced extraction technology and chemical processing systems that require substantial capital investment and technical expertise. The water scarcity impact affects 156 major gold mines, while drought conditions and water allocation restrictions create systematic operational limitation that reduces production capacity. Desert region mining faces water shortage, while many significant gold deposits exist in arid regions, where water access becomes increasingly restricted through environmental regulation and competing agricultural demand. Water transportation costs increase, while mining operations without local water sources face expensive water delivery that can exceed operational revenue during drought periods and regulatory restriction. Water treatment requirements add operational costs, while mining water usage faces environmental regulation requiring expensive treatment systems and discharge monitoring that increases operational complexity. Underground water access becomes expensive, while deep mining operations require sophisticated water management systems and pumping capability that represent substantial ongoing operational cost. The production shutdown analysis reveals systematic mine closure, while operational economics eliminate profitability, creating industry-wide capacity reduction in gold supply shortage. Major mining companies announced closure, while Barrick Gold Corporation suspended operations at marginally profitable mines when operational costs exceeded sustainable levels. Newmont Corporation reduced production while scaling back operations that cannot generate positive cash flow at current cost structure and gold pricing environment. Agnico Eagle Mines delayed expansion while development projects become economically unviable when capital investment cannot generate adequate return through current gold pricing. Kinross Gold Corporation divested assets while selling mining operations that require capital investment beyond expected return capability during current market conditions. Anglo Gold Ashanti restructured operations while focusing resources on most profitable mines while suspending marginal operations that face operational loss. The supply shortage mathematics prove inevitable. Gold scarcity, while mining production decline, cannot meet industrial and investment demand, creating systematic shortage conditions. Annual gold demand totals approximately 4,500 tons, while jewelry, electronics, investment, and central bank purchases create steady consumption that mining supply disruption cannot satisfy. Industrial gold consumption increases, while electronics manufacturing, medical devices, and aerospace applications require gold for essential functionality that cannot substitute alternative materials. Investment demand accelerates during mining shortage, while exchange-traded funds, coin purchases, and bar accumulation create additional demand pressure when mining supply declines. Central bank gold purchases exceed 1,000 tons annually, while monetary authorities increase precious metals reserves, creating official sector demand that competes with commercial market supply. Recycling capacity cannot replace mining, while electronic waste recovery and jewelry recycling provide only 600 tons annually, representing insufficient supply replacement for mining production decline. The alternative supply analysis reveals limited replacement options, while gold recycling and urban mining cannot provide sufficient supply to replace shutdown mining production or meet increasing demand. Electronic waste recycling provides approximately 400 tons annually while representing a small percentage of total gold demand, making recycling expansion insufficient to address systematic mining supply shortage. Jewelry recycling contributes 200 tons while remaining dependent on jewelry owner willingness to sell precious metals during price appreciation periods that may not generate sufficient recycling volume. Industrial waste recovery creates minimal supply, while manufacturing process improvements cannot recover substantial gold quantities compared to mining production that systematic shutdown eliminates. Stockpile releases remain limited, while government and corporate gold inventories cannot provide sustained supply replacement during extended shortage periods requiring ongoing mining production rather than inventory depletion. The price impact analysis indicates significant gold appreciation, while supply shortage mathematics guarantee higher prices despite economic conditions that might normally limit precious metals price increases. Historical mining shortage analysis shows price increases of 100 to 300% during supply crisis periods, while current shortage represents larger supply disruption than previous shortage events. Industrial demand inelasticity prevents demand reduction, while gold applications in electronics and technology cannot substitute alternative materials, creating continued demand despite price increases. Investment demand acceleration during shortage periods typically amplifies price appreciation. While precious metals, investors increase allocation during supply crisis events, creating additional upward price pressure. Central bank competition for limited supply creates systematic buying pressure, while monetary authorities compete for available gold during shortage periods when mining production cannot meet official sector demand. The international implications include industrial production disruption, while gold-dependent manufacturing faces input shortage that cannot be resolved through higher prices or alternative material substitution. Electronics manufacturing concentration in Asia faces particular shortage pressure, while Chinese, South Korean, and Japanese electronics producers compete for limited gold supply, affecting global technology production. Medical device production limitation affects healthcare, while gold shortage impacts medical equipment manufacturing that requires gold for biocompatibility and conductivity applications. Aerospace production faces gold shortage, while aircraft and space technology manufacturing requires gold for critical applications that cannot substitute alternative materials. Financial system implications include central bank reserve limitation, while monetary authorities face restricted gold access during shortage periods, affecting monetary policy flexibility and crisis response capability. The recovery timeline analysis suggests extended industry rebuilding while resuming profitable mining operations requires cost reduction, regulatory modification, or sustained higher gold prices exceeding $3,000 per ounce. Energy cost reduction requires infrastructure investment, while affordable electricity access for mining operations demands power generation and distribution capacity that requires years to develop. Regulatory reform demands political change, while environmental compliance cost reduction requires legislative modification that faces political opposition from environmental advocacy groups. Technology development could reduce costs, while mining efficiency improvements in extraction technology. Advancement require research investment and implementation timelines spanning years. Workforce development requires educational investment while training. Adequate mining personnel demands time and educational infrastructure that cannot quickly replace retired workers. The investment implications include systematic precious metals allocation, while mining shortage provides fundamental basis for gold investment independent of currency concerns or inflation hedging. Physical gold acquisition becomes investment priority, while shortage conditions favor direct gold ownership over mining stock investments that face operational uncertainty during cost crisis. Mining stock investment faces complexity, while company analysis requires evaluation of cost management, regulatory compliance capability, and operational efficiency rather than traditional mining metrics. Gold futures market faces disruption, while physical shortage affects futures contract delivery capability, creating potential for delivery failures and market dysfunction during shortage crisis. The mathematical conclusion proves systematic mining industry collapse, while 73% of operations losing money creates inevitable capacity reduction and gold supply shortage. $2,450 production costs versus $2,050 gold prices create $400 loss per ounce, making continued mining operations economically impossible. Energy costs, representing 67% of mining expenses, create systematic operational impossibility, while electricity and fuel inflation cannot be offset through mining efficiency improvements. Environmental compliance, costs averaging $340 per ounce, create regulatory burden that eliminates marginal mining operations while preventing new development. The $8.9 trillion gold mining industry faces systematic collapse, while cost structure increases exceed revenue generation capability, creating permanent supply reduction and inevitable gold shortage. This is not cyclical mining adjustment. This is industry destruction. The costs are unsustainable. The shortage is inevitable. The collapse is mathematical certainty.